So part of why we learn this is so that we can describe data in ways that make sense to other people that have a common statistical background, right? But another part of it is there are some interesting characteristics of data sets that we can then kind of back out from the standard deviation or the variances, right? So one in particular is this Chebyshev's theorem. And so this is saying for any set of observations, so he's talking about any sample or population, the proportion of values that lie within so many standard deviations, k standard deviations, is equal to at least 1 minus 1 over k squared, where k is any value greater than 1.
Is it greater than or greater than or equal to? The book says just greater than, but Chebyshev's theorem has a solution for just 1.
Oh, yeah, it's probably, the book's probably wrong. I'll look into it. Question mark? Yeah, so if Chebyshev's theorem, if it has a solution for 1, then it should be 1. Then it should be greater than or equal to, yeah. So let's do an example. This does not make any sense without doing an example, right? So we're told that the paint company employees contribute a mean so an average of $51.54 to the company's profit sharing plan. And we're told that the standard deviation of these contributions is $7.51. We are asked at what percent, or at least what percent of contributions lie within 3.5 standard deviations, so it's plus or minus 3.5 standard deviations of the mean. So, for instance, right, 3.5 times 7.51 minus 51.54 is going to be $25.26, and then 51.54 plus 3.5 times 7.51 is going to give us $77.83. So we're trying to figure out what percentage contributes in that range. And so we're going to go and find this using Chebyshev's theorem. So we find the answer is about 92%. The way that we find it is we take 1 minus 1 over k squared. So 1 minus 1 over 3.5 squared, which gives us 1 minus 1 over 12.25, which then equals 0.92. And we take that, we multiply it by 100, and we say about 92%.